Thank you, Kien. So we are starting this presentation about visible light communications and why this technology can be very relevant for Internet of Things applications. So please, Kien, go ahead.
Thank you for the introduction. Hi, everyone. My name is Kien. I'm studying at the Information and Communication Technology at the University of Palermo. Welcome everyone for coming to the European Researcher Night. And I believe after this section today, you will gain more understanding about one of the most promising technology in the near future. And today's section is about Internet of Life. Firstly, let's learn a little bit about the ENLIGHTEM. ENLIGHTEM is representing for European Training Network for Visible Light Communication, and the project is a part of innovative training network. And the objective of the ENLIGHTEM is to develop the innovative technological solution for a new way to transmit data using the LED technology. And a group of 50 young European researchers working together as a part of ENLIGHTEM projects to bring this vision into reality. So I'm delighted to become a part of this family. So let's see who else is also come to join us. The project is collaborate between university, research institutes, large enterprise, small and medium mid-size enterprise. We have all the top-tier university and enterprise in the field across Europe. And to support us, like Nokia, India Networks Institute from Spain, Delft University of Technology from Netherlands, Pure Light 5 from UK, and of course, University of Palermo is one of the main contributor to the ENLIGHTEM project. So that is on Earth on ENLIGHTEM. Let's go to one of the most exciting part for today. What is the visible light communication? The basic concept of visible light communication is to use a visible light that we all have at the home, office, or school for data transmission. Nowadays, we all want to transmit all the data wirelessly, and that is what we're aiming for. And we all want faster speed and want to enjoy all kind of application that we have in the room. Over here, we have the frequency resources. As you can see in this part, it's visible light. And the first part over here, that's what we currently use for all kind of communication. With visible light communication, we have actually a bigger part in these resources where we can utilize it 2,600 times more what we have. And if we're doing the good job in this part, it can bring the whole new technology moving forward. So what is the magic behind the visible light communication? That's using the technology behind a light emitting diode, LED bulb, which is widely available in the market right now. As you can see on the right side, there's all kind of pump that is available in the market, and this can already implement this in so many areas, from lighting to entertainment. So what kind of simple setup for VLC that we can have? The setup contains LED pump as a transmitter, and with the mobile or laptop integrated VLC transceiver down here, we can have a much faster and better data transmission rate compared to what traditional system like Wi-Fi, 4G or 5G that we currently have. Over here, I'm prepared two video One is related to academic research, and the second one is related to the commercial use. So let's see what the visible light communication.
In this demo, the capabilities of OpenBLC
Yes, Ilenia?
No. Now the audio is fine. Sorry.
to transmit video through visible light communication are going to be shown. OpenBLC is an open source visible light communication platform that allows users to communicate using light. Our custom design cape contains an LED to transmit data and a photodiode to receive it. All the processing is performed in a BeagleBone Black. Most of the processing is performed in software, maximizing the flexibility and making the platform customizable. The cape is controlled through the software and firmware designed by us. In this demo, two capes are placed at a certain distance from each other, one as a transmitter and the other one as a receiver. Each one of the capes is connected to a computer. One of the computers acts as a server while the other acts as a client. Both computers are connected through a wire to transmit the control packets. The connection between the computers and the capes is done through a virtual Ethernet connection performed over USB. The only download link is the one created with light, and as it can be seen, it is able to transmit video at a maximum quality of a standard high definition. Nevertheless, if the light is blocked, the video stops, and after waiting some time, the client tries again to get the download stream. Once it gets it, the video continues playing. More details about the system can be found in the demo paper, BLC Square, Enable Video Transmission Using Visible Light Communication.
Ok, se mi permettete di intervenire un attimo perché vedo che nel frattempo sono arrivati due ospiti, quindi benvenuti. Noi in questo canale stiamo parlando di comunicazione con luce visibile. Sorry Kien if I switched to Italian just to introduce our work to our guest. So, questo lavoro è un lavoro che stiamo portando avanti nell'ambito di un progetto europeo. Kien è uno di 15 giovani ricercatori che è stato reclutato proprio per lavorare su questa idea di sviluppare una tecnologia per trasmettere dati con la luce. Quindi io non so se possiamo proseguire in inglese oppure giusto per lasciare parlare Kien, oppure se preferite facciamo noi una presentazione delle cose che stiamo facendo in italiano, cercando sia di illustrare gli scenari applicativi, sia anche di spiegare nello specifico qual è il lavoro che Kien sta facendo. Quindi io vorrei un attimo un feedback da parte degli ospiti che sono appena arrivati per sapere se vogliamo continuare in italiano o se possiamo continuare in inglese.
So what kind of application for visible light communication that we can have? Actually, there's so many. So let's take a look at the first one. How about the smart home and smart building? This housing sector is really need a big push, and that VLC is really suitable candidate to provide that multiple application for that smart system. Let's give example about smart lighting with VLC. We can do light for both illumination and data transmission. That will reduce the high cost for infrastructure for network, and it's even bringing more benefits for operating the house or building. By smart control and operation in the house, no electricity is wasted, and eventually they reduce the electricity bill for every household.
Veramente per qualunque dubbio, sorry Kien if I interrupt again, sentitevi liberi di fare delle domande anche in italiano per qualunque dubbio. Se non abbiamo osservazioni, Kien intanto sta continuando in inglese. Ok, sorry Kien, please go.
VLC for industrial autonomous system. This will also need a big push and advance compared to fix on the disadvantage that the current technology right now have. And VLC can provide a low-cost solution with high efficiency operation. As imagine you stay in factory on the autonomous robots is working. The latency is become a big part, or even the localization of the robots on the movement is need to be accessible and accuracy. That is where VLC can bring to the whole industry. And underwater communication is also a big export for VLC as well. A normal current radio frequency does not work underwater, but visible light can support a high-speed data transmission over the short distance in this environment. And maybe in the future, we can support in the long distance as well. And this could enable the driver and the underwater vehicle to talk to each other and explore a new kind of application as well. Related to intelligent transport system, because so many cars already have a LED lamp, and if we can integrate traffic light, traffic sign, and street light, this can be adopted to LED technology, can bring a massive application opportunity, can be examined over here, and to have an intelligent transport system. Or the autopilot application with the vehicle-to-vehicle communication is also a perfect fit for VLC. Healthcare system is another candidate for VLC. The hospital area is considering is quite sensitive place for any signaling device, including a mobile phone or Wi-Fi equipment, especially around the MRI scanner or in the operating room. And luckily, we find a better solution for that. It's VLC. It's especially safe for human health. And it's also provided a localized high security for data transmission, which is perfect for a hospital. And lastly, how about for aviation? Similar to hospital, airplane is also considering sensitive to any frequency. And VLC LED are already used for illumination, and of course it can be used to provide own kind of application with a high data speed for only traveler in the airplane, and this also bring benefits for the airplane operator by reducing all the cost, infrastructure, and the weight of the airplane. It's the win-win solution for both sides. And in summary, VLC is one of the most promising technology, and which is also gained a lot of attention from the academic and also industry in the recent year. And because it's also a new technology, it's open to have more opportunity to working and developing in the future. And I hope that today's section that helped you gain a little bit more understanding about the visible light communication and also about the LED. And thank you everyone for staying. And if you have any question or any feedback, yeah, I'm ready for